Dear student, myself Rajendra Aaseri, I am assistant professor in computer science department at Government Bangalore PG College, Didwana. In the previous lecture, we discussed about some concept on database and management system. We already discussed about database and management system architecture, roles and various managers and their corresponding impact on the database like buffer manager, transaction manager. Okay, then acid property also we have discussed. Then the need of the database management system and why the file management system is not effective in nowadays. All these concepts we already discussed. Then level of abstraction in database we have discussed. Then some query languages like procedural and non-procedural we have discussed. Then we have discussed about SQL, that is structured query language. In SQL we gone through about various queries based on various concept like select, from, and we can say where, having clause, group by, order by clause. All these concepts we have already discussed. Now in just previous concept we started a new topic on database design technique, and the topic name was entity relationship diagram. In that diagram we discussed about various notations. So in today's lecture we are going through in detail about diagram, right? So in diagram we use various symbols, and every symbol indicate some notation with help of some we can say symbol, and it indicate some different entity, right? So here if you see, the first notation is a rectangle, and inside the rectangle capital E is written. It is a entity set. Entity set, now what do you mean by entity set? Entity set is any real life object which has some certain properties. Properties means suppose I am saying that customer is an entity, a real life object. It has some property like customer can have its ID, customer can have its name, its address, city, and many more attributes, right? So any real life object which has some certain property is known as entity, and collection of entities with similar attribute is called as entity set. So how to just notate or how to represent a entity in diagram with help of a rectangle. Clear? Now next is attribute. Attribute is the property which is satisfying for some entity, okay, which is indicating or defining some entities, right? And the attributes are represented with help of ellipse. If you see here ellipse, and in bracket or in the ellipse we are writing the name of the attribute, right? Next is weak entity set. So what is weak entity set? A entity set which doesn't have the attribute which can be classified as primary key, or we can say a entity without any primary key is called as weak entity set, right? And to denote the weak entity we use double rectangle, and inside the double rectangle we need to write down name of weak entity. Okay, so double rectangle and inside weak entity name. Next is multi-valued attribute. Suppose I am entering in a customer relation and the attribute name is phone number. Suppose a particular customer or more than one customer is having more than one phone number. Suppose I'm just picking only one customer. Suppose customer name is X and phone number entry is corresponding to X is more than one. Then phone number attribute will be called as multi-valued attribute. Why multi-valued attribute? Because there are more than one possible value of this particular phone number value, attribute corresponding to a single customer, right? Next is relationship set. In relationship set we are taking a diamond type of shape, and relationship set indicate the relationship between any two entity. If there are two entities involved, it is binary relationship. If there are three entities involved, then it is ternary relationship. And we can just convert our ternary relationship into binary relationship corresponding or equivalent binary relationship with help of aggregation concept, which we already covered in the previous class, right? So to represent the entity, diamond shape is required. Next is derived attribute. So again, by example I am explaining. Suppose my date of birth is 10 September 1989, right? So this is if suppose I am an employee, so employee, in the employee attribute, one attribute is date of birth. So date of birth is normal attribute and it is represented in the ellipse, right? Now the point arises, if anyone I want to ask from the database that what is my current age. So database can give the answer by subtracting my date of birth from the system date. System date means current date, right? So if we are deriving some attribute with help of some existing attribute, the attribute is called as derived attribute. So in this case, age, current age is a attribute which is derived from the date of birth attribute and system date attribute, right? Next is double rectangle. Inside the double rectangle, if we are writing a relationship, then it means this relationship involved at least one entity which is weak entity. Okay, so it identify a relationship set for weak entity set, right? Now next is if we want to show the total participation and partial participation. Total participation means if all the entity of a corresponding entity set are involved in a relationship in fully manner, then it is called as a total participation of that entity in the corresponding relationship, right? Now, what do you mean by partial participation? Suppose I am taking an example. Suppose in the example I am taking customer and the account relation. Customer and account. So first entity is customer, second entity is account, and in between the relationship is the depositor, right? Means if any customer is having a account in a branch, then that will be called as a depositor. So the relationship between customer entity and the account entity is the depositor, right? This is the relationship. Now if we are saying that every customer is having an account in the account entity, it means it is a total participation of these entity in the relationship, right? If we are saying that at least one customer is present in customer relation which doesn't have any account, so corresponding account entry corresponding to that particular customer is null, then we will say that it is not total participation, it is partial participation of entities in the relationship, right? Now next is primary key. If you want to indicate the primary key, the attribute name will be underlined. So if you see here attribute A and underline, it means it is a primary key. If we are using a weak entity attribute as the primary key, it will be called as discriminator, and to indicate the discriminator, attribute name will be underlined with dashed line. Next, we discussed about cardinality constraint. Cardinality constraint means the relationship between two entity with help of a relationship set. It can be of four type: one to one, one to many to one, and many to many. So many to many means simple this undirected line in the both direction of the relationship. It means it is a many to many relationship. If undirected, it is many, and if arrow mark is there, it means it is one. So left side it is undirected, it means it is many, and right side it is arrow, it means it is one. So many to one relationship. Similarly, next is both side arrow, it means it is one to one relationship, right? In this manner we can just define various type of constraint or various type of concept. Next is we covered about the specialization. For to indicate the specialization, we use relationship is a to indicate the specialization, right? Total generation, double vertical line is a and then single line, it is total generation. So in this manner we can implement the concept of database in er diagram, right? Next, some more symbols are there. Many to many relationship already we discussed. Okay, both side we need to write down undirected line. One side undirected and one side directed, it means it is many to one. Both side one directed, directed, it means it is one to one. then cardinality limits are there, role indicators. Okay, all we have discussed in the previous slide. Now next is, if we want to remove the redundancy, or if we want to reduct or reduce our relational schema, then how to do that? So primary key allow entity set and relationship set to be expressed uniformly as relation schema that represent the content of the database, right? With help of primary key and entity set and on relationship set, we can do this. A database which conforms to an ER diagram can be represented by a collection of schema, right? For each entity set and relationship set, there is a unique schema that is assigned the name of the corresponding entity set or relationship set, right? Each schema has a number of columns generally corresponding to attribute which have the unique name, right? Now if we want to represent our entity set as schema, then how to do that? So once we make a ER diagram corresponding to any entity or relationship, then we can convert that ER diagram into a form of table. Now, in order to make a relation or relational table in the database, we require some attributes. Name of the table can be depending upon the entity name will be name of the table. Now, next is the attribute name. So, attribute name will be the whatever we written inside the ellipse in ER diagram will be taken as attribute or column name in the ER diagram, right? Now, what will be the primary key? So, the attribute in ER diagram which is underlined will be taken as primary key. Okay. So, now see, if we want to represent entity set as relational schema, then a strong entity set reduced to a schema with the same attribute, right? A weak entity set become a table that include a column for the primary key to the identifying entity, strong entity set, right? Suppose payment is the relation. In payment relation, we require some attribute like loan number, payment date, and payment amount. So loan number and payment number might be here the primary key. Why? Because it is underlined in the ER diagram, right? So these two attributes are underlined in the ER diagram. It means these two attributes will be picked as the primary key, right? Next is representing relationship set as schema. So if we want to represent relationship in the relational schema, then how to do that? So a many to many relationship set is represented as a schema with attribute for the primary keys of the two participating entities, right? And any descriptive attribute of the relationship set, right? Suppose a relationship is here is borrower. So in borrower, if we want to represent the attribute, then the attribute of or primary key of both the relation which are involved in this relationship will be taken as the attribute of this relationship. Okay, so while making the relational schema corresponding to a relationship, then we need to pick all the primary key attribute from both the entity and make them as the attribute of the relationship schema, right? Next, redundancy of the schema. If we want to reduce the schema further, then how to do that? So many to one and one to many relationship set that are total on the many side can be represented by adding an extra attribute to the many side containing the primary key of one side. Like example, instead of creating a schema for relationship set account branch, add an attribute branch name to the schema arising from entity set account. So if you see, one entity is account, another entity is branch. In account number is the primary key, next is the balance. Okay, in branch name is the primary key, branch city and asset. So the relationship name will be account branch, and if you see the symbol between account and account branch relationship, it is a double horizontal line. It means it is a total participation And if you see in the right side, it is a single arrow, it means it is a one, means many to one cardinality it is satisfying. Okay, means from account relation, more than one account can be related to a single branch. In a single branch there can be more than one account exist, right? Because it is a many to one relationship, right? Next is redundancy of the schema. For one-to-one relationship set, either side can be chosen to act as the many side for one-to-one, right? That is, an extra attribute can be added to either of the table corresponding to the two entity set. If the participation is partial on the many side, replacing a schema by an extra attribute in the schema corresponding to the many side could result in the null value. This is very very important. If the participation is partial, suppose participation is partial on the many side, it means some entries will be left out and that corresponding value will be put as the null value. Okay, corresponding to that. Next is the schema corresponding to a relationship set linking a weak entity set to its identifying strong entity set is redundant. Redundant means that can be having some duplicacy. Example, the payment schema already contains the attribute that would appear in loan payment schema. Why? Because in loan payment schema, loan number and payment number is involved. So payment schema is already having payment number and loan number. So the redundancy is always present. So we need to reduce this redundancy. Okay, so upcoming lecture some more new concept. Thank you.